let's calculate the integral from 0 to positive infinity of sine x over x dx. First, I'm going to introduce a parameter alpha. Let's say I'm going to use the integral 0 to positive infinity. I'm going to multiply the original integrand by some e to the negative alpha x and sine x over x dx and call that I of alpha. Because obviously the integral is with respect to x, but as alpha changes, of course, this definite integral value changes as well according to alpha. So that's why it can be viewed as a function in terms of alpha. And of course, this integral is definitely convergent just by using the Dirichlet test, which I will make a video in the future explaining Dirichlet test. And also, first of all, I'm going to differentiate with respect to alpha. Alpha I prime. Of course, it's also perfectly legal for me to differentiate inside first, then do the integration. I'll also make a video in the future explaining why. But in this video, I will just focus on the calculations. So let's do that. 0 to positive infinity. Like I said, integrate, differentiate with respect to alpha. So x can be now treated as a constant. All right, so right now, I'm going to, first of all, using chain rule, right? Chain rule to this one. But sine x over x is just a constant. We can copy that down. Right? Sine x over x. Now, using chain rule, again, x is a constant. Right? Negative x coming out. Negative x coming out. Then I'm going to multiply by itself, e to the negative alpha x. Right? So this time, x cancelled out. Right? So negative 0 to positive infinity. And e to the negative alpha x sine x. Right. Also, the benefit is that x down the bottom is gone, right? That's what's causing the trouble. Now we can just easily integrate this relatively easy integral. Right, that's the whole benefit. And so that this should be relatively easy to integrate. Right? So I'm going to treat maybe integral by parts. Maybe this is u, this is dv, u dv, uv, e to the negative alpha x, negative cosine, evaluated from 0 to positive infinity, minus 0 to positive infinity, u dv, v du, what's du? Du, differentiate this one. Negative alpha, e to the negative alpha x, v du, u dv, v du. V is negative cosine. Negative cosine becomes positive, right? And yes. So still one. And so the positive infinity, right? Plug in here. And so e to the positive x, or alpha is fixed. Let me say alpha bigger than 0. Right? So that it's 1 over e to the alpha x. Right? X becomes positive infinity. So obviously 1 over positive infinity approaching 0. Right? So since 0 insert into here, cosine 0 is 1, right? 0 is 1, e to 0 is 1, negative 1. So 0 minus negative 1 becomes 1. So this whole thing becomes 1. And for this part, I'm gonna try to, so negative 1 minus this one. This time I'm going to, for this integral, right, integral by parts, again, just apply it again. So let me just take out the alpha, right, take out alpha. Alpha coming out. So minus alpha bracket, and this time u dv, right? U dv. U dv. What's v? V is sine x, right? So e to the negative alpha x sine x 0 to positive v minus 0 to positive infinity u dv du. This time u dv v du. Copy down sine x, then sine x, differentiate this, right, minus alpha, and times e to the negative alpha x minus alpha coming out plus alpha, right, if I'm not mistaken, and so that it's, yes. And so positive infinity, right, plug into here, I have what? Still I have 0, right, approaching 0. 0 plugging here, also 0, so this is gone. And so that in the end I have, if I denote this as I, and also I think this integral is also the same as that one, or exactly the same. So in the end I have negative I, right, here negative I, equal to negative 1, I expand everything out, negative 1, I have, here I have alpha multiplied by this one, right? Alpha squared times I, and negative plus alpha square I, and so that I should be equal to 1 over 1 plus alpha squared. Right, so that means I of alpha is in fact equal to negative I, right? Negative I. Negative, but negative I is just negative 1 over 1 plus alpha squared, right? Which means, no, it's I prime, right? I prime of alpha is equal to, so which means I of alpha, its antiderivative should be equal to negative arctangent of alpha plus c. We're going to determine c. Now let's estimate this I of alpha absolute value, right? It's bounded above, I claim. So that is less than or equal to, take the absolute value inside, 0 to positive infinity, absolute value of, but this is already positive no matter what, right? E to the negative alpha x, absolute value of sine x over x dx. But knowing that well-known inequality over, if x is within 0 to half pi, right? We have the well-known inequality, that is sine of x must be less than or equal to x. This is easily verifiable. And also if x is in the open interval greater than half pi to positive infinity, of course we have sine x is absolute value less than or equal to 1. Well, 1 is less than x, right, in this region. Right? And also maybe perhaps at absolute value. Well, it doesn't matter. Right? Doesn't matter. Sine, yeah. And yeah. So what I'm trying to say is that in the end we can just over this 0 to positive infinity, easily just replace sine x absolute value just with x absolute value, right? In the end, it's bounded above by 1, right? So that is less than or equal to 0 to positive infinity e negative alpha x times 1 dx, right? Definitely bounded above. But this is easily calculatable, right? This is easily doable. This is equal to, let's see, negative perhaps e to the negative alpha x over alpha. Right? Double check, differentiate that. Right? Negative of alpha coming out, chain rule, right? Cancel out negative alpha at the bottom, e to the negative, yeah. So evaluate it from 0 to positive infinity, which is equal to, so positive infinity, 1 over, I think it's approaching 0. All right, 0, 0 minus 0, plug into that. 1 over alpha. 0 minus negative 1 over alpha. 1 over alpha. That is this. Of course, then we can just let alpha approach positive infinity. If that's the case, right, we have I of alpha absolute value is not only greater than or equal to 0, but also less than or equal to 1 over alpha. And so as alpha approaches positive, this will approach 0, right? Squeeze theorem. So this as well approaches 0. Yes. So which means as alpha approaches positive infinity, this equation, right, left-hand side approaching 0. So alpha approaches positive infinity, arc tangent positive infinity, half pi, negative half pi. So C has no choice, right? C must be equal to half pi. Right, definitely. And so which means I of alpha is equal to negative arc tangent alpha plus half pi, right? Also equal to that, right? So I'm just copy down this result, right? I of alpha equal to negative arc tangent alpha plus half pi. Right. Now, this time we're going to let alpha approach 0. Yes. This time we let alpha approach 0. Of course, alpha is greater than 0. Approach 0 from the right-hand side. Right. So that it's also legal for us to let alpha approach the inside the integral. I'll make a video explaining why it's legal in the future. Right, but for now, let's just accept it as a fact. So which means as alpha approaches 0 on the right-hand side, we approach, because it's continuous, arctangent 0, half pi, right? The same time equal to, so this is continuous, right? Alpha approaching 0, approaching e to the 0, approaching 1. 0 to positive infinity. Sine x over x dx. Yes. So that's the answer.